radius. Glare. In the human eye, the opening of a pupil is controlled by its iris, which depends upon the intensity of light received by the eye. We know that already I told you. I told that whenever we are, our eye will not be able to be see more intensity light. Means, especially we are not able to see the sun in midday afternoon exactly at 12 o'clock 1 o'clock like that. We cannot able to see that intensity of light received by the eye. In the human eye, the opening of pupil is controlled by its iris, which depends upon the intensity of light received by the eye. If the eye is exposed to a very bright source of light, bright source means you are having a very 1000 candle power lamp, the pupil of eye contracts automatically in order to reduce the amount of light admitted and prevent damage to the retina. This effect is called glare. Very example is whenever we are riding on a bike in night times, whenever the other person will focus his light onto our eyes, we cannot able to see the road. That process, that phenomenon, we call it as a glare. Glare is defined as the brightness within the field of vision of such character so as to cause discomfort and interference in vision. We cannot able to see some discomfort will be there, that we call it as a glare. You see here, whenever especially driving, here there are two lamps are there. In that particular time we cannot able to see that clearly, we cannot able to see that clearly. That phenomenon we call it as a glare. Here also the driving, whenever we are driving. Next definition is a lamp. It is defined as the visible radiations emitted by it in lumens per watt. Usually the light source do not radiate energy only in the visible spectrum. The radiant energy is also accompanied with infrared and ultraviolet radiations. Sunlight produces majority of radiations in the visible spectrum. The tungsten lamp produces small radiations, so its efficiency is very poor. The tungsten lamp, whatever we are using in olden days, the filament lamps we are going to use, and that lamp produces a small radiations, and its efficiency also very poor. The lamp efficiency, this is an wavelength, and this is an efficiency in percentage, 20%, 40%, and 100 like that. First 5000 wavelength we are having an ultraviolet, 500 to 5000 to 10,000 we are having a visible radiation. Once if it will be going for about 10,000, infrared radiation and sunlight. These are, here we are going to assume with three different categories: sunlight, gas filled lamp, and vacuum filled lamp, where we are going to, in which we are to see the wavelength, the efficiency of sunlight will be more, that means about 80%. Similarly, the efficiency will be going to be for gas filled and vacuum filled lamp. As the wavelength increases, the efficiency of that particular lamps and source of sunlight also will be going to be an increases. The efficiency fluorescent lamp is more than the tungsten lamp. The efficiency of a fluorescent lamp is more than the tungsten lamp. Next, we are having a reflection factor. whole of the light incident on a reflecting surface is not reflected. Some portion of it is absorbed by the surface. All it is we know that whenever the light will be falls on a surface, the complete light will not going to be reflecting. Some portion of light will be going to be absorbed by the surface. The ratio of the reflected light to the incident light is called it as a reflection factor. How we are going to define a reflection factor is nothing but whenever whenever the light will be falls on a surface, some light will be going to be absorbed by the surface and some light will be going to be reflect. The ratio of reflected light to the absorbed light we call it as a reflection factor. Loss of illumination. The illumination E will be depends upon the mainly luminous intensity and distance between the source and the surface and the direction of rays also. We know that the illumination E, for example, at our houses we are having a light. As if you are moving away from the source, then the illumination will be reduces. As if you are going closer to the light, then the illumination will be going to be increases. Now how we are going to tell that in terms of loss of illumination we need to tell that is normally we can say, but scientifically how we are going to prove and how we are going to tell that we call it as a loss of illumination. The illumination on a surface depends upon the luminous intensity, distance between the source and surface and the direction of rays also. Always the illumination will be depends upon these three things. First one is that distance between the source and the surface. Second one is direction of rays. And third one is luminous intensity. These are the three things. It is governed by the following laws. First one is an inverse square law and a Lambert's cosine law. These are the two laws. This diagram shows that inverse square law. The inverse square law shows that as if you are away from the source, the intensity of the light will be going to be a decreases. See here, it states that the illumination of a surface is inversely proportional to the square of the distance of the surface from the source, that is E is directly proportional to I by d square, where E is illumination and I is luminous intensity and d is distance between the source to surface. Distance between the source to surface. The inverse square law is nothing but it states that the illumination E is inversely proportional to the square of the distance of the source from the surface. Lambert's cosine law. Lambert's cosine law is nothing but it will in which direction it will be going to project that light. Either what is the angle that it will be depends upon the cosine of the law or cosine of the angle also. This law states that the illumination on any surface is proportional to the cosine of the angle between the direction of the incidence flux and perpendicular to the area, that is E is equal to I cos theta or I cos alpha. The cosine law, this cosine law, Lambert's cosine law states that the illumination of on any surface is proportional to the cosine of the angle between the direction of the incident flux and the perpendicular to the area E is equal to I cos theta. How you are going to produce the lightning by using an electrical methods? These are the following are the methods of producing light. First one is by developing arc between two electrodes. Second one is by passing a current through a filament. Third one is by electric discharge through vapor or gases. These are the three methods to produce the lightning. First one is by developing an arc between two electrodes, that we call it as an electrode lamps. By passing a current through a filament, that we call it as a tungsten filament lamp. By electric discharge through vapor or gases. Here in these cases we are going to use some gases and vapors, that is a mercury vapor lamp, sodium vapor lamps, hydrogen lamps. These are the different types of light producing methods in electrical. Arc lamp, we know that the principle of an arc lamp is that what is meant by an arc? Whenever the two electrodes will be going to touch together, then automatically it will be produces some arc. The principle of an arc lamp is that when two electrodes carrying current are separated through a small distance, an arc is stuck between them. The arc lamp were used in the past for street lighting purpose, but nowadays these are used when extreme brightness is required. Whenever you require any more brightness, then we are going to use an arc lamp. Mostly commonly used arc lamp is carbon arc lamp. These arc lamps are used in the street lighting purpose mainly, but nowadays whenever you require an extreme brightness, then we are going to use an arc lamp. The best example for arc lamp is a carbon arc lamp. This is the old type of lamp and is still being employed in cinema projectors and searchlights, where you are going to use in cinema projectors and searchlights. It consists of two hard carbon electrodes. The diameter of the positive electrode is double to that of a negative electrode. The negative electrode is generally fixed and positive electrode is placed in adjustable holder, and the process is manually or automatic. Just what we are going to do here, we are going to touch the two electrodes, then arc will be produces. That arc we are going to be used in the form of illumination, that we call it as a carbon arc lamp. The diameter of the positive electrode is double. Whatever you are going to consider that electrode, the diameter of that particular positive electrode is double as compared to the negative electrode, and the process is manually or automatic. That process we can do by an automatically or manually we can do. The arc consists of carbon vapor surrounded by orange red zone of burning carbon and pale green flames. Continuation. When the lamp is off, the two electrodes are touching each other due to spring pressure on positive electrode. When the supply is on, a large current is flow through the electrodes. The temperature of carbon electrode is increased, and thus the positive electrode is pulled away against its spring pressure through a small distance by coil, and thus an arc is struck between the electrode. This arc is maintained by transfer of carbon particles from one electrode to the other electrode. See, this is a carbon arc lamp we are having. This particular level from positive electrode to negative electrode Thus, after some time of operation, positive electrode become hollow and negative become pointed. That's why positive electrode is made double than negative electrode. The arc in carbon arc lamp, 85% of light is given by positive electrode, which produces high intensity of light, and only 10% by negative electrode and 5% by air. The temperature of positive electrode is 4000 degrees centigrade and that of negative electrode is about 25,000 degrees centigrade. The illumination efficiency of such lamp is about 9 lumens per watt. See here, carbon arc lamp. For maintaining the arc, a minimum voltage is required, where L is the length of an arc in centimeters. Next, filament or incandescent lamp. The working principle, we know that a room heater is switched on. It gives out red light with heat at the working temperature of 750 degrees centigrade. And at this temperature, the radiations are mostly in infrared red regions. This working principle is used to develop the filament lamp. We know that this is a bulb, screw, bayonet base, inert gas, support. This is an incandescent lamp. What we observed, what we know, this type of lamp, filament, all the thing. When an electric current is passed through a fine metallic wire, it is another metallic very thin wire. It raises the temperature of wire. At low temperature only heat is produced, but at higher temperature light radiation goes on increasing. At low temperature only the heat will be produced, but at high temperatures the radiation goes on increasing. As filament lamp consists of fine wire of high resistive material placed in an evacuated glass bulb, this type of lamps are operated at the temperature of 2500 degrees centigrade. A tungsten filament is enclosed in an evacuated glass bulb. To improve its performance, some chemical like argon or nitrogen gas are filled. Properties of metal for filament. We cannot take any metal, that it must be following some properties. Particular filament, whatever you are, why you are going to use a tungsten filament only, because it must be having a high melting point so that it can be operated at high temperature. It must be having high specific resistance so that it produces more heat. It must having a low temperature coefficient so that filament resistance may not change at operating temperature. Next, we are having a low vapor pressure so that it may not vaporize. High ductile so that it may be withstand with mechanical vibrations.